Let's talk about point of contraflexure. A point of contraflexures exist in a situation when a beam is which is either simply supported or of cantilever type or of indeterminate or with fixed ends is subjected to transverse loading. Now the point of contraflexion is made up of two words, contra and flexure. Contra, the meaning of contra is opposite, and the meaning of flexure is bending. So its meaning is that at this point the beam changes its shape from sagging to hogging or hogging to sagging. In more technical terms, it means bending moment change its sign. So if it is positive before the point of contraflexure, then it will become negative after the point of contraflexure, and vice versa. That means at point of contraflexure, the value of bending moment will be 0. Now there is other term which is shear force, another parameter, another causal term, that is shear force. It may or may not be 0 at the point of contraflexure. When in most of the cases, in 99% cases, shear force is non-zero at point of contraflexure. Even if, however, in some application it becomes 0 at that point, then how it impact the behavior of bending moment around that point. So if shear force is also 0, bending moment will be 0. That is the definition of point of contraflexure. But if shear force is also 0 at the point of contraflexure, the bending moment doesn't change its sign before and after contraflexure. So if it is positive before point of contraflexure, after passing point of contraflexure it will be again positive, but it will have 0 value at point of contraflexure. It's like the zero line, the axis of zero deflection will be tangent and have slope 0. Now shear force, it's basically change in bending moment with change in distance. It's mostly occurs in indeterminate beams. In indeterminate beams are that beams, the indeterminate beams are that beams which have both of their ends totally fixed. Means whatever transverse load you apply on the beam, the end will not move, the end will not bend, they will remain straight. So in those cases you have 6 parameters to solve the equation bending. So you have to find 6 parameters, the horizontal deflection, vertical deflection, these two on both sides, so these are 4 parameters, and then moment on both sides. So there you have to find 6 parameters, but you only have 3 equations, 3 static equations. One is equilibrium in force equilibrium equation in x-axis, other is force equilibrium equation in y-axis, and then you have moment equilibrium equation. So how can we find point of contraflexure if we know the equation of bending curve on that beam? Simply put m equal to 0, because we know at point of contraflexure m is 0. So that is it for today, the point of contraflexure.